see if we can answer the questions. Survey and assessment, let's see here. The websites that have been looked at for data careers was done surveying large amounts of people. We're going to highlight it for just a moment, so we can highlight just a little bit of this. The others, hopefully they'll be able to do so. By surveying large amounts of people, that large amounts of people is going to come back to us in a moment. Your goal will be to do a survey. We got that part done by what we did last time of your own and add and compare and contrast. That's the big deal. Now that we have a survey, can we compare what we did with what the United States did in total? In doing so, you will be tasked to think about data gathering and evaluate its significance. In other words, the idea that they're hoping is that you will think about the process of, hey, how do we gather information? This topic of statistics is being used in that. And applying your findings to the larger population as a whole. Figure out, by the 20 people we surveyed, can we say something about what job most people will probably try and choose, or anything about that? So that's where we're beginning this process. Let me see, no, the markings won't go with me. Whether you can do this with a pencil, you can check. I'm going to check off what we've done. That is, you will create your own survey and collect data from your peers. Those are done on a small scale. The survey should generate some interesting information. This side we could probably check mark because we did do that. So you're good there. Pick a career cluster that has some of your favorites. Again, I guess the check marks don't have to be super big. I made mine a little bit big because this paper I think eventually you're going to be turning in for the unit. Create a survey to see who else picked that career cluster. Okay, that's that survey that we gave out. Step 2, let's see. So step 1, we got that taken care of. Step 2, survey at least 20 individuals to find out how many would like to be in that career cluster. All right, we got that. 3, even though I wish there was a way for me to connect this so that each time the marks don't have to move, but I'm going to go with it anyway. Step 3, make a visual pie chart. That one we may come back to. Make a visual pie chart of your data to use in your final presentation. I think I will figure out a way to really kind of get that done, but it might be a little tricky because of how many choices there were on the list. There are 25 choices, so to make a pie chart, we'd have to cut that chart into 25 pieces. Maybe we might make it like a kind of like a square chart where we put the 25 squares and color in 1 or 2 just to kind of get a feel rather than a pie chart. So we might come back to step 3. Let's see, now I'm trying to get to. All right, now we can start answering some of the questions based on what we did with our survey. Does anyone remember how many people we were going to get to based on what it asks on here? How many people were supposed to take the survey?
20, at least 20.
So we did the 20, so you can go ahead and write in your answer right there. We did 20. The next question will be, and again, use pencil just in case we have to change any of this. What is the population of survey? In other words, who did we survey? And for these, since we probably will try to understand, we'll write a complete sentence. The population was, who did we survey for these surveys?
Students.
And let's do more specifically students at OFY. And that way, we have that information there. Question 4 says, find the proportion or percentage of peers that are interested in your career cluster based on total peers surveyed. So here's what's going to wind up happening. And I don't know how much I'm supposed to just declare it to you directly. Here we're going to start with a fraction, because we're going to try and create a percentage. That fraction is going to be how many people out of the total. So I'll put how many. No, I'll put your cluster. Your cluster. Your cluster. I don't know how. I want to say short, so it's not written there, but I guess I'll put how many. How many, and if you write how many of your cluster out of 20, how many of your cluster all over 20? And the reason out of 20 is, of course, that's the number of students that we surveyed. So I'm going to return to you your survey where you chose your cluster 1, 2, and 3. The reason we chose a 1, a 2, and a 3 is just in case there wasn't enough information in a 1 or a 2 or a 3, when we did it to the 20 students, we'd have some backup. For you, your cluster, we're going to make your cluster your number 1. Okay? So when we're going to compare what they did compared to what you chose, we're choosing it with your number 1. So when you get it back, highlight your number 1. We're going to switch to another. So in order to create a histogram to gather data for question number 4, and question number 4 is find the proportion of percentage of peers that are interested in your career cluster based on total peers surveyed. We know it's out of 20 because we did 20 of them. If I were putting an equal sign, that 20 would still be on the bottom, and then we're going to figure out how many were in the groups. Now, no group had like a super lot, because there are 25 different areas. Even if everybody chose one area, still some areas wouldn't even have been chosen. So let's see if we can create a histogram with that really fast, and then see if we can answer some more questions, which is where we are. Once we do the survey, now it's a matter of doing the math that goes along with the survey. As we get a tally for each one, we'll put the tally below the group. Technically, each one of these is its own interval. Last time we did where we had the interval from 70 to 79.91. In this case, each topic is going to be its own interval. So here we go. Let's see if we can do this thing. The first few will record, and then the others will just, the answer will just pop up on the screen, so I'll pause it, and then we'll do that. So here we go. I'll find out how many of them you have. Does anyone have a survey whose first choice was architecture and engineering? If you have one, you'll hold up one finger. If you have two of them, you'll hold up two fingers. I'm going to look at mine, and then we'll put our fingers up. See what we got on the first two. All right, fingers for the top row. I need fingers. I don't have any, so okay, we got a 1. None for, all right, so only a 1. So again, as we're creating a histogram, we put a 1 there. Arts and design is the second one. Any fingers for number 2? 4? Dang, you got 4 of them for number 2? All right, and these are 4 1s. I'm nervous. I'm gonna come over there and look at this. And 1, so 5 altogether on that one. 1, 2, 3.
Can we just put the number, or does it have to be?
You'll put the tallies initially, just as for creating a frequency histogram. You can, but in the end, you are right. You are going to put a in the container for the first one. You put a 1. The container for the second one, you'll put a 5. Oh no, I got a 5 on that one too. We'll do one more on camera, and then from there we'll do it, and the rest will just pop in for those who are here. Building and grounds cleaning. Is there a number 1 next to the third? Okay, nothing there, and nothing mine. So you leave it blank, put inside. You can put a. Should we put a 0? Leave it blank. I guess we'll put a 0. Those who are watching, we're going to pause and then finish the rest, and then the answer will pop up there after we do this. So we've been adding some numbers, and so the numbers are there. We're going to turn it off and add some more, and then pop it up maybe. And so this completes. Yeah. This completes the histogram, which normally these numbers, we'd make rectangles at the top. We're not going to do it this time, but what we normally do, we'd have a line going across the top for making a histogram. And again, we have it going up here, and this would be 1. What's the highest number to go up to? 5. You don't have to, maybe for a few, just to show that we were making a histogram. We don't have to do it for all of them since we made a histogram the other day, but just so that you can have a mini histogram. The only problem is trying to separate these. It can be a little tricky, how wide they are, and that's why we wouldn't necessarily do it in this format. But just so that we would have made a histogram. There's 1, and then there's a 5 of the next door neighbor. The only trick is how wide to make them. I'll just do 2 more, 1 and a 1. Let's see. Next door neighbor is a 1. 2 1s. I'll do 2 more 1s. And all right. So here we have, let's see if I'm recording that histogram. Yes. So I just started with this histogram. Of course, this would be a 5. This guy down here, if I were putting in the numbers, he'd be a 5. He'd be a 1. A 0 right here, now that you need the numbers. A 1 and a 1, and so on. So that when you look at making a histogram, it's really just a box table, or rather, not a line graph, box graph, where they give up the numbers. All right, so now is where we need to answer that question. So let me give you a chance to be writing this. I'll pause on that for a moment. What was your cluster, your number 1 cluster, Oswaldo, and then I'll ask Marcos.
Mine?
Yeah, yours.
Oh, I chose military.
All right. Oh, yours is one of the ones that I did it to. So either you're going to check, what were your other 2? Because since we didn't have any for military on the school survey, I wound up using your 2 or your 3. What was your 2?
My 2 was construction and extractor, and the third one was entertainment and sports.
I'm going to recommend that we, just to make it interesting, use the entertainment and sports because it has 3, but if you chose to use construction and extraction, you can use that one. If you had to choose between the 2, based on the numbers that are up here, which would you choose?
I'll choose
You know what? Actually, let me back off. Let me ask if you use construction and extraction, since entertainment is sometimes an obvious one to choose, and we'll see how it plays out with the numbers. If we need to do it again with the other one, then we will. Which one what was your choice? Your 1, your 2, and your 3? On your own first.
My 1 was architecture and engineering.
You have the 1. And what was the number 2?
And my second one was installation, maintenance, and repair.
Installation.
My third one was construction and extraction.
So all of yours do 1s. What was your first one again?
Architecture and engineering.
All right, then just use your 1. And what I'm trying to show is once we start doing some of the work, for some people the percentage will be different than others, but if we all have the same numbers, there won't be anything interesting to compare. Okay, so we have that. So now that we've created a histogram based on the 20 surveys that we have, put how many of your percentage are interested. There are 20 percentage of peers that were interested in your cluster. Okay, yeah, no, that's right. We did 20 surveys, 20 of your peers. I'll put the number on top of 20 that agree with yours. I know they're small numbers. After that, if you put that number, whatever that number is, then we need to turn that into a decimal and then turn it into a percent.
So for this one, for mine, do I have to add it to this one, to the histogram?
No. So yeah, so your personal one won't be included. Right now, we're just taking the number of people from the histogram, and we're going to put that number above 20. Because the histogram is the information we got counting up everybody else's and not our own. Okay. Once you have that, and actually let me recollect your individual ones.
So count these out?
So you're going to find the find the cluster that matches the one that's your top cluster, or in your case it was construction. And then we're going to find out how many number, what the number was that we put in that little bubble. Once we know what the number was that we put in that little bubble,
I go 0.5.
okay, good. So that gives you your decimal. So for example, I'll use one that Oswaldo is doing right now, and then I think yours. I think Marcos may come up with the same thing.
Yeah, it is.
All right. So both of you had only one person in your cluster. When they divide that by 20, they get a 0.5.
No, it's 0.05.
Okay. Like that?
Yeah.
Yeah. Usually I put that extra zero in front, but the 0.05 got it. Can either you remind me how to turn a decimal into a percent? Something what we do. Let's see if you remember from a long time ago. It has to do with moving the decimal how many times and in which direction.
2 to the left.
2 to the left is close. If we're going from percent to a decimal.
So 1 to the right.
2 to the right, Yeah, so you both kind of worked that out good. So to turn this 0.05 into a percent, you go 1, 2, and then you add, we're going to put it now right here, so that, I'm just going to rewrite it so that it doesn't get mixed up with the decimal answer. To go to percent, so you can see the work of a statistician. Some of it is just really compiling the numbers. Once they compile the numbers, then I would imagine a computer program 1, 2, add the percent symbol, so that equals 5%. So 5% of the school's population of options for youth population chose your cluster. Now, I don't know if it's okay to say 5% of OFY Fontana 2 population, or can we say all of OFY? Let me ask that question. Based on our survey, can we say it's 5% of all of OFY because there are centers all over the place? Or do we only get to say it's 5% of OFY Fontana 2?
Yeah, they use Fontana 2.
Yeah, because while it's true, they do belong to OFY. Because they're here, it may say something different than somewhere else. And that's going to be part of the conversation. When people do surveys, and they want to say 20% of the population wants this, they want more laws about, or they might even do a percentage. Some percent of the population wants medical marijuana to be legalized, or recreational marijuana to be legalized, which they're going to vote on in about a week. If they only took the survey in one area, then it may not really be representative of everyone, and that's kind of what they want you to experience. Like, okay, I'm going to be able to guess some things about who wants to do what at options, but really I probably have to just say options, Fontana 2. And let's see that. Let's see what our next thing is. What's the next question we have in line? Make inferences about, let's see how many they want. The next question is, now that we've done the survey, we got the 20% based on your cluster, they're going to ask you to make inferences about the population. Do this for this population. Go ahead and put, we'll start with OFY, Fontana 2. OFY Fontana 2. And it's kind of small because I think you need space. Make inferences about population based on the survey results you got. Let's find out the question. Let's see what you know, what you may remember. If you've heard the word inferences before, what does inferences kind of mean? If you don't know what that means, then we're not sure what they're asking. And they want us to either be able to do 1, 2, or even 3 inferences in this section. You have to guess what inferences mean, or might you guess?
Percentage.
Okay, percentage, that's a possibility in terms of having a guess. Let me say some inferences about some stuff, and then you're like, oh, I kind of see what they're saying. let's see. Either of you play, even if you don't play a lot right now, uh, is it GTA? Yeah, GTA. Have you played GTA before?
I played before.
Before? No. Video game with military? Military video game? No. All right. Either one. All right. So here, I'm going to make an inference. You played GTA before. An inference it might be Marcos likes hurting people. All right. Now, my inference could be wrong, but based on playing that game, he likes to, he might like to hurt people. Military. I could probably make the same inference on your side that Oswaldo likes hurting people. An inference is when you just guess something about someone based on some information that you might have. Another could be Oswaldo likes the military. It doesn't have anything to do with hurting people. Maybe playing the game. GTA inference would be like, you know, I like just doing something that's completely different than what I normally do. You know, the game's kind of this world where you're doing all kinds of stuff, whatever. So the question is what inferences can be made. So now, the way they're applying that is this. Now that you found out that 5% of the OFI Fontaine population chose your cluster, what inferences can you make, just period, about either your cluster, about the students at OFY, anything else about the students themselves, about how many people might try to go into the same field that you're going into, if you're going into it. So that's what they mean. So I'm going to give you a moment to actually try to come up with maybe two, three in a perfect world, but see if you can come up with two inferences. Do the inferences need to be correct? Not necessarily. Again, whatever I guess about him like military, maybe not. Maybe it's the only game in the house, which is why he's playing. Maybe GTA, a young older brother had it and said, "Hey, play it," you know. So what you infer may not necessarily be right. But let me have you take a few moments to do. We erased it already, but the percentage that we found. 5% of the people agree with my cluster. What might I be able to infer about the population, the people we surveyed? About the population OFI altogether, Fontana 2, based on the survey. Right there. All right, what you got, Oswaldo?
Based on the 20 people who I gave a survey to, only one out of the 20 chose a career cluster that I was interested in. So basically, 5% was. I'm still continuing, but
all right.
it was basically 5% out of 100. 1% equals 5%.
All right. And that's a good start. The only challenge with that is an inference, kind of by definition, can't be something that we know for sure. By that I mean, 20 people were surveyed. Okay, we know that for sure because we gave it out. One person chose it. We know that for sure because it was on there. That one is 5%. Okay, so we know that for sure. So far, the things you've shared are things we know for sure. We have to kind of guess something about that information for it to kind of be an inference. So I like kind of where you started, but in the end, eventually we're going to have to try and guess something about the students who are here, and I'll try and guess something in a moment to kind of see what I'm saying about that. Marcus, what's one that you may have written?
5% of students probably like designing since they have chosen architecture and engineering.
All right, I can kind of use that one. The part that we don't know for sure is that they like it. Like why they chose it, we don't know. But the fact that he's saying they liked it, well, he's basing that on the fact that, read it again so I can hear how you said it.
5% of the students probably like designing since they chose architecture and engineering.
Okay. So that one is close and not close. It is. No, it's the liking that makes it an inference. But 5% we know for sure. Oh, okay. No, none of it we know for sure. We know of the survey, 5% chose it. But the population is all of Fontana 2. So any room I look into, I can say, okay, yeah, but 5% of them probably like it. Well, how can you say that? Well, based on the survey, where 5% of the 20 marked architecture. One, we can infer that they liked it. They didn't. We don't know for sure. They may have chosen because their dad wants them to be an architect or whatever. But we assume that they liked it. And then two, the entire population. So that one actually kind of hits. The main thing is there's some things that we don't really know. We don't really know if 5% of everybody here will like it. Well, we don't know if 5% of everybody will do it. 5% of our survey did it, but not of everybody. We don't know that. And then two, we don't know will they like it. So that one kind of hits. Did you have another one, or just that first one was your main one?
Just this one.
Okay. Did you have another one, or was that first one just your main one? All right. So let's do this. Try and get up here, which we didn't do. It would have probably been a good idea. In inference, it says, so now, the conclusion reached on the basis of evidence and reasoning. And in our case, it's that survey. Let's see here. There should be no. Let's see. They give an example sentence. There should be no inference drawn from the fact that he chooses not to be a witness. In other words, if you want to be a witness in a case, somebody might guess like, oh, you probably know something, or maybe somebody's threatening you. And inference is always this idea that we don't know whether or not something happened. We have to kind of guess it. Let's see, his emphasis on order and health, and by his inference, cleanliness, and by inference, cleanliness. In other words, if he likes things to be order and healthy, then we can infer that he likes cleanliness. Did you get a second one? What did you say for the second one?
Only 5% of the 20 students we surveyed chose architecture and engineering, which means they might be interested in that.
Okay. All right, and basically the same. Basically the same statement. Say it again. Let me hear if you're talking about the students who took the survey or the whole center. What did you say?
Only 5% of the 20 students we surveyed chose architecture and engineering, which means they might be interested in that field.
Okay. That one, the only challenge on that one, where it has a good start, is because they said this thing about the population, we got to identify who the population is. But in our case, we decided the OFY, Fontana 2, the whole center, is the population. Those who took the survey is so that we can figure out something about the population without having to ask everybody. So we asked just 20 students, and based on what they said, well, now we're going to say junk about everybody based on that. So the second one, because you said stuff just specifically about the 20, that one may not be the best for an inference, just because it's about the 20. And that if the question was about the 20, the survey group, then I think that would be right on target, because you could say, oh, we guess that they like that. We don't know, but because they chose it, chances are they did like it. So on that one, put a little question mark next, in just in case we have to choose one, we choose that first one. All right. What did you put down this time, Oswaldo?
I don't know anything, but I was thinking the same thing as he was, but in a different way.
Okay. Can we say anything about the center? Can we infer rather? To infer is the verb, inference is the noun. Can we infer anything about the other 95% of students here at Fontana 2 option? In other words, if 5% seem to like that category, what can we say about 95% of the students? Which would be the rest of the students. Yours was construction? Is that the one we're using? And yours is architecture and engineering? Okay. So in both cases, what can we say about all the other 95% of students? If 5% we can infer like that category. And I'll say it this way, as I see you both thinking, kind of an either-or thing. If 5% like my cluster, and 95% don't like my cluster, the other group that would make up 100%. And so in both cases, that's another inference you can make. You know, I was going the direction that they like. Okay, 5% like, I can say that about them. But as an easy second inference, you can say the opposite. Well, if only 5% like my thing, then the other 95% that I need to add it up to make 100, they don't like my cluster. Well, the truth is, it isn't that they don't like it. It could be that they like another cluster better. To like something else doesn't mean I dislike yours. It just means that I like something better, which I guess still could be dislike. All right, we'll leave that for now. We might work on some inference statements, but at least, you know, one, in order for an inference to be there, what makes something, let me hear what you all might say, what makes something an inference? There's something that makes it different from a fact to an inference.
Two people not, or two groups not liking the same thing, or
Close. Compare Oswaldo's first statement, which was fact, to your first statement, which was an inference. What was the difference between the two?
That I use facts and he did.
Right, right. In order for an inference to kind of be that, if we know for sure all the pieces of what we're saying, then it's not an inference. There has to be something about it that we don't know for sure. And in this case, what they're trying to have us do is use a fact. We took a survey, we got 5% on our survey, to now guess stuff about everybody else around us. So let's keep moving. Let's move this thing out. Let's see what's the next question in line. We got an inference. The next one, this is one we're going to have to actually dig in and get our computers in a moment. But let's see what part 2 says here. Because as we're looking at these things, you're always thinking, okay, for sure, I need a 2 to be near mastery. A 3 gets me above that. Let's see what we're going to do with the computer on here really fast. All right, so let's see what we got here. It says, I can compare my survey to one done for the Bureau of Labor Statistics, or I can accurately explain which is more reliable. Let's see, and then there's like, I can compare, and I can do one or the other, compare them. Or I can explain why mine is more reliable than theirs, or theirs is more reliable than mine, which one I can depend on more, or I can do both. I can compare my numbers with theirs, and then say why I think either mine is more reliable or theirs. So let's see if we can find some information so that we can go ahead and do that. Down here at the bottom, let's see what instructions they kind of give us to be able to do that.
there's a short.
All right, so we're going to have to go into the computer. See, find out if the percentage you got in your survey, that's that 5%, matches that of the Bureau of Labor Statistics found. Compare the 2 percentage values from your survey and the Bureau's. Which survey results should be more accepted and why? Okay. As we look up for this question here, part 1, to find a percentage, we always need a total. So we're going to need a total, like in our survey we had 20, and we got 1 out of 20 to be the percentage. For the whole United States, we have to find out what total they're using and how many they got. So let's see if we can find out how hard that'll be. All right, so I'll start part of it recording. Bureau of Labor Statistics, the BLS. Let's see, who are you? Sure. BLS.gov/OOH. I'm going to look up one category, different than what you're looking at that way. At least, we won't just kind of do it for you. All right, so let's see. Where can we find this information? I'm looking up installation, maintenance, and repair. You're looking up construction and data tools, publications. What else? Beta. All right, maybe let's look at the group first. Maybe click on the group, it might say something in there. Let's see. Looking up installation. All right. And let's see. I have the different titles. I wonder if... Okay, they have some information here. Employment, installation, and repair. Projected to grow. All right. For those who are still listening, of course, we're trying to look up so you can have an idea of what to do in the case that all this won't be repeated next class. About as fast as average, which result in 365 new jobs. Median wages that in May. Ratio is higher than median annual for all occupations. They have the different jobs, but they don't say how many people. Are you finding anything, Oswaldo, or are you in the middle of something different? I know. Say that again? Let's see, data tools. Top picks. Series report. Maps. At this point, we'll pause the videos since we're doing what you would do if you're trying to find information, looking it up.